Welcome to our introduction to Internet Protocol version 6 or IPv6. As the successor to IP version 4, IP version 6 addresses the limitations of its predecessor and is crucial for the future of Internet connectivity. IP version 6 is a vital technology that addresses the challenges posed by IP version 4 while paving the way for future innovations in Internet connectivity. IP version 6 uses a 128-bit address space, allowing 2 power 128 addresses, which is an extremely large number. IP version 6 addresses are written in hexadecimal format divided into 8 groups separated by colons. Address types are unicast for single device, multicast for group of devices allowing data to be sent to multiple receivers at once, anycast for a set of devices where data is sent to the nearest one. IP version 6 addresses support a hierarchical format which helps with efficient routing and organization of addresses. It allows for flexible address distribution, making it easier to manage large networks and accommodate more devices. IP version 4 has several deficiencies that hinder its effectiveness in a rapidly evolving internet landscape. These include limitations in address space, service integration, multicast support, quality of service, security, mobility, and header design. As a result, the transition to IP version 6 was initiated to address these shortcomings and accommodate the future needs of networking. The deficiency of IP version 4 are IP version 4 has about 4.3 billion addresses which are running out due to the increasing number of devices. IP version 4 struggles to support new services like real-time application, for example, video and voice. While IP version 4 supports multicast, its capabilities are limited compared to new standards. The quality of service in IP version 4 are insufficient for forwarding the important data traffic. IP version 4 does not include security features, making it vulnerable to attacks. Security must be added separately. Mobile IP support in IP version 4 is limited, making it hard for devices to stay connected while moving between networks. And finally, IP version 4 header is complex and variable in length, which slows down processing and limits new features. The transition from IP version 4 to IP version 6 introduces significant changes in the header structure, aiming to improve scalability, efficiency, and the functionality for modern networking needs. The key differences are header length. IP version 4 has a variable header length, while IP version 4 has a fixed length 40 bytes. IP version 4 addresses are 32-bit, while IP version 6 addresses are 128 bits, allowing for a vastly larger address space. IP version 4 includes fields for fragmentation, while IP version 6 uses extension headers to handle fragmentation differently. In terms of error checking, IP version 4 has a header section, whereas IP version 6 does not. It relies on transport layer protocols for error checking. The IP version 4.6 header is designed to simpler and more efficient for routing and processing compared to the IP version 4 header. IP version 6 header fields are version 4 bits. This field indicates the version of the protocol. For IP version 6, this value is always set to 6. Traffic class 8 bits. The traffic clearance field is used for marking packets for quality of service handling. It allows the network to prioritize certain types of traffic, for example, voice or video over others. Flow table. The flow table field is designed to identify packets that belong to the same flow, enabling special handling for those packets. This is useful for application requiring consistent performance, such as streaming media. Payload length 16 bits. This field indicates the length of the payload that follows the header, measured in bytes. It helps routers understand how much data to expect in the packet. Next header 8 bits. The next header field identifies the type of the next header in the packet. This could be a transport layer protocol like a TCP or UDP, or an extension header used for additional functionalities. Hop count 8 bits, similar to the time to life field in IP version 4. The hop limits specify the maximum number of hops that the packet can pass through before being discarded. This helps prevent packets from circulating indefinitely in case of routing loops. Source address 128 bits. This field contains the 128-bit IP version 6 address of the packet sender. It is used for routing the packet to the source if needed. Destination address 128 bits. The destination address field holds the 128-bit IP version 6 address of the intended receiver. This is crucial for delivering the packet to the correct endpoint. Thank you for watching.